Hello.
Yes, ma'am.
Can you able to see the PPT? PPT दिसतात का व्यवस्थित?
Yes, ma'am.
ओके. किती जण अटेंड झालेत? 8. ठीक आहे. We will wait for 2 minutes. As I have already discussed, today we are having test of 20 marks. Okay. Before means in the first slot where we will complete the lecture, in a second slot we will take test. Okay, meanwhile those students who has not saved their name with roll number, you have to save your name with roll number. Who is this? Arbaz Tamboli. You have not saved your roll number. Why? Arbaz? Hello Arbaz. Hello. अरबाज तुमचा रोल नंबर सेव्ह करा नंतर. अटेंडन्सला परत प्रॉब्लेम येतो. ते दरवेळेस रोल कॉल लिस्ट चेक करावी लागते. मीनवाईल इथं कसं डायरेक्ट रोल नंबरने केलं की मला पण इझी जातं. अरबाज आवाज येतोय का? Okay. Now see participant total 17. Now we will start. Now as we know that microprocessor and microcontroller, so basic point is nothing but, first point it is nothing but feature. Now you tell me the answer first. 8085 is how many bit long?
8 bit.
Okay, 8 bit. सगळ्यांनी द्यायचंय. Okay, it is 8 bit long. Why it is 8 bit long? Because of 3 reasons. Why fast? चला पटकन रिव्हिजन संपू म्हणजे नेक्स्ट पॉइंट बघता येईल आपल्याला टेस्टच्या आधी.
ALU is 8 bit.
ALU is 8 bit long. Second?
Internal data bus and register 8 bit.
Good. And last?
And external bus is 8 bit.
Good, Payal. Now it is 8 bit long. Operating frequency is?
3 megahertz.
Good, Swapnali. 3 megahertz. Then data bus is of?
8 bit. 8
Good.
bit.
Okay. Address bus is of?
16 bit.
16 bit. Combination of 8 bit is called as? Combination of 8 bit is called as?
D0 to D7.
1 byte. Okay. 8 बीटच्या एका ग्रुपला नाव काय असतं? बाईट. BYTE. ओके. नाव मग मी असं पण म्हणू शकते 8085 is 1 byte microprocessor किंवा 8 bit because 8 bit is also represented as 1 byte. Okay. Now next, due to 16 address lines we can able to access 64 kilobytes of memory. Okay. Now next feature is accumulator, that is 8 bit long. DC, DEHL, these are the general purpose resistor which is also 8 bit long. There are 2 temporary resistor W and Z which is also 8 bit long. Flag resistor, it is also 8 bit long. Again program counter and stack pointer is 16 bit long. It is having separate control bus to carry control signals, and there are 5 addressing modes from which we can take address, that is immediate, resistor, direct, indirect and implied. Okay. Next main part is nothing but the architecture. Architecture part, first part contains LU unit which contains 4 blocks: accumulator, temporary resistor, flag resistor and ALU. ALU is, again, what about ALU? We can say it is 8 bit long. It is arithmetic and logic operation. It is used to perform arithmetic and logic operations. Now 2 operand means for the operation is received from accumulator and temporary resistor. After performing arithmetic and logic operation, ALU store the result back into the accumulator, and the status of resistor is replicated in flag resistor. So next part 1 is nothing but the accumulator. Accumulator is again 8 bit long. Again it is the special purpose resistors. Again means it is used to carry one operand in arithmetic logic unit. Also it carry the result of operation. Okay, we can means it is a user accessible, that is user is going to access this. Then there is a special purpose resistors. बिफोर दॅट टेम्पररी रेजिस्टर. टेम्पररी रेजिस्टर डब्ल्यू आणि एल टेम्पररी रेजिस्टर्स आहेत. 4 पॉईंट डब्ल्यू एल चे लक्षात ठेवायला सांगितले होते. फर्स्ट पॉईंट, टेम्पररी रेजिस्टर इज नॉट अवेलेबल फॉर द युजर. W and Z are the two temporary resistors. Again, these are 8-bit longs and for any operation, second operand is automatically come into the temporary register by the system. So B, C, D, E, H, L, these are the 6 general purpose registers. Again, each register is 8-bit long, which is used to store address or the data. Okay, or the result of any arithmetic and logic operation. Now तुम्ही म्हणाल मॅडम ऍड्रेस तर 16-bit असतो. तर 16-bit ऍड्रेस मधला लोअर हाफ पार्ट एक रजिस्टर स्टोअर करतो, अप्पर हाफ पार्ट एक रजिस्टर स्टोअर करतो. So if you want to access 16-bit data, then we need to use the register pair, that is B, C, D and HL. User cannot specify the pair. These are the fixed 3 pairs, that is B always pair with C, D always pair with E, H always pair with L, and HL is a by default means pair. So this up to this it is a revision part. Now today we are going to see very important part, that is the flag register. Before the flag register, you just remember this diagram. By seeing this diagram, what is the use of flag register?
Store the result.
Status of
To store, not to store the result, it is used to store the status of result. Now here now one new concept is there, status of result. So तुम्ही विचाराल मॅडम रिझल्ट स्टेटस म्हणजे काय असतं. तर whenever we are going to perform arithmetic and logic operation, as we know that this is the arithmetic operation, addition, subtraction, multiplication and division. We have not seen about multiplication and division. It is same as that of our decimal multiplication and division. जशी आपण पहिली दुसरी शिकलो होतो मल्टिप्लिकेशन वगैरे, सेम इथं करतात, फक्त 1 आणि 0चं असणार आहे ते. And logical operation, these are the logical operations. So after performing arithmetic and logic operation, there is a updation, means there is a means particular result is generated, and whatever the status of result is there, it is stored in the flag register. So this is the diagram of flag register. Okay, as we know that, what about the flag register? It is a 8-bit long. Okay, so out of these 8-bit, we are going to use only 5 bits. It is very important part, because again out of 74 instruction, your maximum instruction depend upon flag registers. Okay, so flag register ही अतिशय महत्वाची कन्सेप्ट आहे, आणि त्यात तुमचं मीन्स यू आर नॉट दॅट मच अवेअर अबाउट द DT टेक्निक, digital technique, so you have to put maximum attention towards this concept. So if there is any doubt, you can immediately ask or put your question in the chat box. So flag register means what? Flag register is the register in which status of the result is going to be shown. Now flag register is a group of flip-flop used to give status of different operation result. Now here again one new term, which is one chapter in the digital technique subject, that is flip-flop. Now for this point, you just remember what is meant by flip-flop. It is the memory unit which is used to store single bit. Means what? If you want to store 8-bit, then you need 8 flip-flops. One flip-flop store 1 bit, which is either 0 or 1, whatever it may be, but it is able to store only 1 bit. So it is a memory unit which store 1 bit. So what is flag register? Flag register is a group of flip-flop. किती flip-flop असणार आहेत? 8. Out of these 8 flip-flops, we are going to access only 5 flip-flops. Okay, used to give, which is कशासाठी असतं? So which is used to give the status of different operations result. The flag register is connected to ALU, as you already seen this diagram. It is always connected to what? It is connected to ALU. Okay, now once an operation is performed by ALU, the result is, once the operation is performed by the ALU, the result is transformed on internal data bus, and the status of result is transferred on internal data bus. Internal data bus means where it is used to store the result into the accumulator. Okay, and later on the status of result will be stored in the flip-flop, that is in the flag registers. Now how many flags are there? There are 5 flags. Which are these? Now see here. They are called as a 0 flag, carry flag, sign flag, parity flag, auxiliary carry flag, etc. So 0, carry, sign, parity and auxiliary. How they are represented? Now see this diagram. It is very important point, which is also going to use in the microcontroller unit. Okay, so see here, D0, D1, D2, D3, D4, D5, D6 and D7. There are total 8 locations. Okay, first location, that's why the name D0. Second location, that's why the name D1. तुम्ही म्हणणार मॅडम सेकंड एंड वन का, तर वी आर स्टार्टिंग फ्रॉम 0. ओके, third location D2, fourth location D3, fifth location D4, again 6th D6, D5, 7th location D6 and 8th location D7. So what is this? These are the flip-flops which is used to store single bit which may be 0 or which may be 1. इथपर्यंत कळालं का? हॅलो,
Yes.
सगळ्यांना कळालं का? काय कळायला पाहिजे तुम्हाला आता? फक्त 2 गोष्टी. व्हॉट इज मीन बाय फ्लॅग रजिस्टर? फ्लॅग रजिस्टर इज नथिंग बट द ग्रुप ऑफ 8 फ्लिप फ्लॉप विच इज यूज टू स्टोअर द स्टेटस ऑफ रिझल्ट. हे 2 सेंटेन्स कळाले का? हॅलो, चॅट मध्ये सांगा बरं. चला मला फास्ट, मला कळलं ना तुम्ही काय आन्सर देता ते. कळालं असेल तर येस म्हणा, रिपीट हवं असेल तर रिपीट म्हणा. बरं ठीक आहे, आधी समजून घेऊ आणि मग रिपीट करू. ठीक आहे, जाऊ द्या, नका सांगू, आधी इथे आपण बघू. सो इथं काय लक्षात ठेवायचं तुम्हाला? यू नीड टू रिमेंबर 2 थिंग्स. व्हॉट इज मीन बाय द flag register? Flag register is nothing but the group of flip flops. How many flip flops? 8 flip flops. That's why flag register is 8 bit long. What is the use of flip flop? To store single bit which may be 0 or may be 1. Okay, out of these 8 flip flops we are going to access only 5 flip flops. Okay, now which are the flip flops we are going to access? That is D0 we are accessing. D1 there is a X or what we can say, don't care. X represent unspecified bit termed as a don't care. Okay, की जे आपण यूज करत नाही म्हणून तिथे आपण फुली केलेली आहे. So D0 carry bit, again D1 is don't care bit, D2 is a parity, D3 again don't care, D4 is a auxiliary carry, D5 again don't care, D6 as a 0 and D7 as a S bit. Okay, now see one by one. First bit, which is it? D0. Okay, CY stands for
Carry flag.
Carry flag. Hence before, have you ever heard the name carry?
Yes.
Have you heard the name carry? Yes or no?
Yes.
Carry minati.
Carry म्हणजे काय लक्षात आहे का? तुम्ही सांगा. What is mean by carry?
Minati.
What is mean by carry? Fast.
Carry minati.
Carry? Yes? It is used in addition or subtraction?
Addition.
Addition.
Okay, it is used in addition. Now, what is mean by carry? It is nothing but the हातचा. Okay. तुम्ही काय लक्षात ठेवायचं? Carry is nothing but हातचा. Now, आता कुठे हा जनरेट होणार आहे? तर 8th बीट मधून. Now, आता इथं काय लिहिले बघा. हे बीट आता D0 आहे. D0 काय? What is D0? It is a flip flop or 0th location of the flag register. It should be 0 or it should be 1. Okay. So when it should be 0 or when it should be 1? Now see, if the operation performed in ALU generates a carry from D7 to next stage, then carry flag is set, else it is reset. Now याचा अर्थ काय? की whenever we are going to perform any addition, okay, for addition we are having 2 operands, okay, A and B, okay, which is in A register, second operand in B register. Okay, after performing the addition, whatever is the result, okay, for example consider 2 plus 3, okay, 2 plus 3 result is 5. If in that 5, if there is a carry generation from D7, that is D7 means which location? 1 2 3 4 5 6 7 8. यातलं कुठलं लोकेशन आहे? D7 means 8th location. Yes or no? If from
Yes.
that location, if carry is generated, then and then only D0 bit should be 1. Otherwise it should be 0. कळालं का? ठीक आहे. I will explain all the things. Then we will see the example. After seeing the example, you can ask me the question, means doubt that I have not, means repeat पाहिजे किंवा काय कळालं नाही ते. आधी पहिले पूर्ण सगळे फ्लॅग समजून घ्या काय येते. Okay. So second is the auxiliary carry. What is meant by the auxiliary carry? It is an operation performed if an operation performed in ALU generates the carry, okay, from lower nibble. आता इथे एक word आला nibble. Nibble is nothing but a combination of 4 bits. If there is a combination of 8 bit, we term it as a byte, B-Y-T-E. Same way, if there is a combination of 4 bit, that is 1100, 0000, okay, 1010. So these are the combination of 4 bits. So it is termed as a nibble. That's why the representation is D0 to D3. Means how many bit present in the nibble? 4. Okay. So if the operation performed by LU generates a carry from D3 bits to D4 bits, then this flag is going to set, otherwise reset. Okay. Next one is the zero flag. Zero flag means what? If after performing the operation by the ALU, if the result is 0, then this flag is going to set, otherwise reset. Now sign flag means what? If MSB bit is 0, then the number is positive, and in that case it should be means what? 0. For example, 2 plus 3, 5 means what? Plus 5. That's why this bit should be 0. But if we are performing 2 minus 3, answer is minus 1. So your result is minus. That's why this bit should be 1. Okay, and next one is a parity. Parity means how many 0 bits are there in the result. Okay. Okay, what is meant by MSB? MSB is nothing but the most significant bit. There are two concepts, LSB and MSB. LSB means least significant bit. Least significant bit means D0. For example, जे युनिट प्लेसला असतं. ओके, फॉर एक्झाम्पल आता मी जर तुम्हाला सांगितलं 135, ओके, 135. 5 काय आहे? युनिट प्लेसला आहे. 3 काय आहे? 10th प्लेसला आहे. 1 काय आहे? 100 प्लेसला आहे. ओके, मीन्स व्हॉट? If 1 multiplied by 100 plus 3 multiplied by 10 plus 5, then we get the number 135. Okay, so in that case 1 should be treated as MSB and 5 should be treated as LSB, that is least significant bit. Now consider this number 7132020. Okay, in that case 0 is at LSB and 7 is at MSB. The number which is present to the extreme left is called as MSB. Okay, now next one is a sign flag. Sign flag, when your answer is positive, this flag should be 0. When your answer is negative, this flag should be 1. Next one is a parity flag. Parity flag checks how many number of zeros present in your answer. If the result contains even number of ones, then this flag is set. And if the result contains odd number of ones, then this flag is reset. आता हे फक्त मी एक्सप्लेन करून सांगितलं, एकदा रिवाइज करते आणि मग तुम्ही तुमचे क्वेश्चन्स विचारा. ओके, आता रिव्हिजनचा पार्ट आहे, सो आपण मराठीतून हे करू म्हणजे तुम्हाला जास्त लवकर कळेल. हे बघा, D0 to D7 असे टोटल 8 फ्लिप फ्लॉप्स आहेत. या 8 फ्लिप फ्लॉपच्या ग्रुपला आपण काय म्हणतोय? फ्लॅग रेजिस्टर. फ्लॅग रेजिस्टरचा यूज कशासाठी असतो? तर जो काही रिझल्ट आलेला आहे, आता हे सगळं मशीनच्या आतमध्ये होतंय, सीपीयू मध्ये होतंय. ओके, बिंग ऍज अ युजर आपल्याला काहीच कळत नाही की काय होते. आपण देताना इथून 2 देतोय मीन्स किंवा 3 इनपुट म्हणून देतोय, पण आज सिस्टीमच्या काय होतंय आपल्याला कळत नाही. का कळत नाही? कारण की व्हॉट एव्हर वर्क डन बाय द सिस्टीम इट इज इन द बायनरी फॉर्म. अँड बिंग ऍज अ युजर, बिंग ऍज अ ह्युमन, वी आर नॉट अवेअर अबाउट द बायनरी टर्म्स. ओके, 1 तास जर मी 3 ते 4 नुसतं 00011101011 असं म्हणत बसले तर तुम्हाला काहीतरी कळेल का? नाही कळणार, कारण की ऍज अ युजर बायनरी इज नॉट अंडरस्टँडेबल टू द युजर. मग आपण काय करतो? सिस्टीमला असं तयार करतो की सिस्टीमचा जो काही रिझल्ट आहे ते या स्टेटसला दिसले पाहिजेत आणि या स्टेटसवरून आपण रिझल्ट बद्दल कमांड करणार. मग आता कोणकोणते स्टेटस आहेत? तर 5 स्टेटस आपण दाखवतो. पहिल्यांदा बघा, कॅरी फ्लॅग. कॅरी फ्लॅग म्हणजे काय? जर आपण एखादं ऑपरेशन सांगितलं, नॉट ऑलवेज नेसेसरी दॅट इज ऍडिशन, मे बी इट मे बी सबस्ट्रॅक्शन असेल, मल्टिप्लिकेशन असेल, डिव्हिजन असेल किंवा लॉजिकल ऑपरेशन्स असतील. सो व्हॉट एव्हर इट मे बी द ऑपरेशन, इफ देअर इज अ मीन्स जर तिथून D7 म्हणजे 8th बीट मधून कॅरी जनरेट झाली तर हा ऑटोमॅटिक फ्लॅग 1 होणार, अदरवाइज तो 0 असेल. नाउ वन्स अगेन नीड टू टेक अ केअर दॅट it is the flag which is not updated by the user, it is updated by the system. So whenever it should be 1, ते काय आपण करत नाही, ते सिस्टीम कडून होतं. जसा रिझल्ट आलेला आहे त्या रिझल्टचा स्टेटस बघून सिस्टीम या रजिस्टरला ऑटोमॅटिकली 0-1 फील 0 1 करते. बिंग एज अ युजर आपण हे ऍक्सेस करू शकत नाही, आपण फक्त बघू शकतो आणि तिथली जी काही व्हॅल्यू आहे त्याच्यानुसार आपण मीन्स प्रेडिक्ट करू शकतो की काय आन्सर असेल. ओके, मग आता फर्स्ट बघा, कॅरी फ्लॅग जेव्हा इथं सेट होईल तेव्हा आपल्याला काय कळणार की D7 बीट मधून कॅरी जनरेट झालेली आहे. पहिली गोष्ट. ऑक्झिलरी कॅरी फ्लॅग जर इथं सेट 1 असेल तर आपण बघितल्यावर आपल्याला काय कळणार की ठीक आहे, D4 बीट मधून सुद्धा म्हणजे D3 बीट मधून कॅरी जनरेट झाली आहे आणि ती D4 मध्ये ऍड झाली आहे. हे मला कधी कळलं, मी या फ्लॅग कडे बघितल्यावर. हा फ्लॅग कुठं रेप्लिकेट होत, कुठं दिसतो आपल्याला, स्क्रीनवर. जेव्हा आपण प्रॅक्टिकल करू तेव्हा तुम्हाला हे म्हणजे याच्यासाठी मायक्रो कंट्रोलरचे आणि प्रोसेसरला किट आहे, मायक्रो कंट्रोलरला तर तुम्हाला म्हणजे सॉफ्टवेअरच आहे, तर तिथे तुम्हाला दिसतं 0चं 1 1चं 0 झालेलं. सो ऑक्झिलरी बाय सीइंग द ऑक्झिलरी कॅरी फ्लॅग बिंग एज अ युजर व्हॉट वी कॅन say there is a generation of carry from D3 to D4 bit. Okay, next one is a zero flag. If an operation performed by ALU result 0 value, now if I have given one operation to the ALU that is 3 minus 3, what is the answer? 0. Okay, so means what, your answer is 0, so that in that case 0 flag is said to be 1. Means by seeing this flag what we can predict, that is answer result is 0. Okay, if it is not 0, means if this flag is not set, then what we can say, result is other than 0. Okay, now next sign flag.